What is quantum gravity? Part 2. Imagine that the universe is split into microscopic chunks, trillions of times smaller than any particle in existence. This is the basis of loop quantum gravity, the second big idea to explain gravity on the smallest scales. In this theory, spacetime is comprised of a series of microscopic nodes, which combine to form spin networks. These networks span across the whole universe, creating a megastructure called quantum foam that makes up spacetime. But how does this quantum foam create gravity? If we zoom back down, we see that spin networks assign a unique numerical value to each region of space, as well as the edges that connect these chunks to each other. These numerical values modify the spin properties of particles across one microscopic unit of time. Over large distances, the small quantum changes compound into the forces we perceive as gravity. The main reason why loop quantum gravity is more interesting and cooler than ideas like string theory is background independence. In string theory, particles must be attached to a static, unchanging spacetime, but since gravity affects spacetime, the theory breaks down on the smaller levels. But in loop quantum gravity, that doesn't happen, since gravity is an innate property of space. But loop quantum gravity also has one fatal flaw. When we try viewing the universe as a patchwork of chunks, the model breaks down. For instance, when scientists observed the patterns of photon bursts from many light years away, the patterns in which they were received implied that space was not chunked after all, but instead one continuous piece. All this to say, the question of quantum gravity remains, to this day, pretty much unanswered.